So sometimes people struggle with the domain of functions, and all the domain of a function means is for what x values can you plug into f of x, being your function, is the function is defined. F of x is defined for what values of x. And that's really all it means. Now, a better question is, how is a function undefined? Well, there's two ways things can be, well, there's a number of ways, but it's two main ways that something can be undefined. The first way is if you have a function, f of x is equal to, let's say, x over 0. Well, you can never, ever, ever have 0 in the denominator. So if you do, I'm going to run out of room. Well, that says denominator for all those who are super curious. You can never have a 0 in the denominator. So if you do have a 0 in the denominator, then you are out of luck. Your function is not defined there. And the other way this can happen is if you have f of x equals radical x and x is less than 0. Because remember, if x is less than 0, you have, well, for example, f of x equals, and let's say you have -2. Well, that's not possible because the square root of -2 is not a real number. So I'm going to give you three possibilities. I'm going to erase this real quick. And these are three types of functions that you might run into and have to do a little bit of explanation. So the first function is a polynomial function. Now, a polynomial function is something that looks like this. F of x equals, say, 2x to the 5th minus 4x to the 4th plus x cubed minus 3x squared plus 5x minus 2. It doesn't really matter what it is. As long as you notice this, we have a greatest index, or greatest integer exponent, and that's 5, so this is a 5th degree polynomial. And none of these are radicals, and none of these, there's no denominator here. Even if we had, okay, let's do something real quick. Even if I did this, even if I made this 1/3 x cubed, it doesn't actually, I mean, it is a fraction, but it doesn't truly affect that x because I can't make that x go into the denominator. So the domain for this, if you were to graph it, you would see it goes from -infinity to positive infinity, and that's true for all polynomials. The very, very basic polynomial, y equals x, same domain as that. Y equals x squared plus 4, same domain. So that's just the domain for polynomials. Second would be a rational function. And rational functions are functions, this is kind of an ugly color, so this looks like a nicer green. Rational functions are of the sort f of x equals x over x plus 2. Well, like I said before, you just can't have a 0 in the denominator. So what I do is I set the denominator equal to 0. And I subtract, x equals -2, which means when x equals -2, this function will not be defined. It will be -2 over 0. So the domain is -infinity to -2 or -2 to infinity. Another way to write it is if you said -infinity to infinity if x does not equal 2. That's also, I'm sorry, if x does not equal -2. And that's also perfectly legal. I'm going to show you one more of these questions because this is kind of important. I'm running out of room, so I'm going to erase the polynomial function up there. And it sounds like my kids are giving my wife a hard time, so I might have to cut this video short. But stay with me. I'm going to give you one more, and it's going to look like this. This is another rational function. And it could say x squared plus 5x plus 7 over x squared plus 5x plus 6. Now, some people say, whoa, look at the numerator. Well, the numerator is completely irrelevant. We don't care what the numerator is. So I'm going to set this equal to 0. I'm going to say x plus 3 times x plus 2 equals 0, which means x equals -3 or x equals -2. -3 squared is 9. 5 times negative 3 is negative 15. 9 minus 15 is negative 6, plus 6 is 0. Negative 2 squared is 4. Negative 10 is positive 6. Plus 6 is 0. So x can't actually equal this. So your domain is going from negative infinity to negative 3. Or negative 3 to negative 2. Or negative 2 to infinity. Oh, goodness me. It sounds like there's complete chaos upstairs. So I'm going to have to do this last part very, very quickly. The last one I wanted you to see, and I'm going to change to, ooh, this purple looks gorgeous. So this purple one is radical functions. And here's the deal. You have something like f of x equals x minus 3. Just remember, you can have a 0 underneath, so I'm just going to say x minus 3 equals 0. Add 3. I got x equals 3. And so my domain is anything that's 3 or greater. So it's going to be 3 to infinity. That should look like an infinity. And it does not. 3 to infinity. I'll do one more for you. If I have f of x equals, let's say, x squared minus 4. Well, this is a little bit tricky. So I'm going to say, all right, x squared minus 4 is equal to 0. Know that this is x plus 2 and x minus 2 is equal to 0. So x equals negative 2 or x equals positive 2. Well, now you're going to have to be clever about this. What I'm going to do is I'm going to make a quick number line. And I'm going to see where this is defined. I'm going to say, all right, I have negative 2 here, I have positive 2 here, I have 0 right in the middle. If I know that negative 2 and positive 2 are going to be included, but I want to see which way these are going to go. If I plug 0 in, I get 0 squared minus 4 is a negative 4, so this is no good. No good. So with a little luck, it should work when the number is 2 or greater, or less than negative 2. So let's try a negative 5. Well, negative 5 squared is 25, minus 4 is 21. That's great. Positive 5 squared is 25, minus 4 is 21. Radical 21 is the value, so my domain is from negative infinity to negative 2. Oh, sorry, it should be included. Or 2 to infinity. Alright, well, I'm done with the video. It sounds like all is calm on the home front, so good for me. Hope you enjoyed this. Take care.